Well, it's a beautiful day in the neighborhood to talk about doors. And I'm not talking about the Jim Morrison doors either. I'm talking about just regular ass old doors and how to unlock them. This is the third part of probably, this will be the last entry in my series because I think I'm pretty much done. I am building a application and set of hardware to handle answering my apartment intercom easier. I'm slated to have hip surgery pretty soon, so should be able to answer it through my cell phone, and also I should be able to let people into the building. And also, just as a bonus, I hooked up my actual front my apartment door to this, so you can unlock it without having a key. So anyway, that's the recap of what's happening. The thing that's actually new is since my last video, which I'm sure you watched, this is fascinating, is this stuff to the right of the Raspberry Pi, which is another door unlock, which is my apartment, my apartment door. So I can just walk up to my, through my hallway and click the button, and I don't have to have my key. And this is essentially the same as the front door unlock. It's wired slightly differently because the power supply is in line with the solenoid. Over here, we didn't have to do that because this VC10M thing took care of it for us, but we actually hook up the normally open to the ground of the PSU wire, and we hook up the plus 12 volts of the PSU to the red of the inside door solenoid, and then hook up the ground of the solenoid back to common in the relay, and all that works. And that is driven through GPIO pin 24. Oh yeah, baby. I'm going to switch over to sort of how this actually all works in practice, and we'll take a look. So the first thing I'm going to do, you won't be able to hear anything. There's no actual buzz of the inside door, but we should see some stuff fly by on the terminal here, which I'll do that just so we can see the new stuff. Okay, so if I buzz the inside door, let's see. There we go. Okay, so it's buzzing. That means that the solenoid is open. And then it relocked it. It just unlocks temporarily for 5 seconds. And then if I talk to the front door, now I'm using a Manjaro Linux setup where if I push this button, it actually doesn't do anything. Of course, because why would it? Why would it? But I actually do have an application that it should invoke to do that, and it will be as if I push this button here. So we'll do that. And now we can hear the sound of the dulcet tones of my front door. Yep, and you can hear me echoing back through the front door microphone. And now I'm going to buzz the front door. You'll be able to hear the buzzer. And that is that. So that is the entire operation of this thing. Soup to nuts. This is the output of the door client application, the script that runs on the Raspberry Pi. There are some continuing issues, some minor problems. There's one other feature of this thing, which I went over in my last video, which is when someone pushes the front door call button, sometimes it works, and it will actually page a number of phones, between 0 and whatever number of phones I have set up in Asterisk to receive the front door page. And when any of those phones answer, the rest of the phones stop ringing, and you'll be talking to the front door right away. That continues to be problematic. I had a issue with trying to use rpi.gpio to actually capture the GPIO input event for the call button, and I'm sure I'll put a little clip of me freaking out, but in here. But if I would send voltage to one of the door unlock pins, you know, saying, from one of the door unlock pins, it would often trigger the input pin for the call button detector. So anytime I unlocked the door, it would actually page me, which was silly because that's not what it's supposed to do. And I tried all kinds of software stuff. I measured things with scopes and did all kinds of stuff. And then one time I was actually turning my soldering iron on and off, and it paged me. Turned my box fan on and off, and it paged me. And I was like, what the F, man? So on a hunch, I just said, okay, I have no other choice. I'm going to try GPIO 0, which is an alternate GPIO pin library for the Raspberry Pi and other systems. And when I did that, that stopped. That went away. Now, the interesting part about that is that it still uses Raspberry RPI GPIO under the hood. So I'm sure I'm just holding RPI GPIO wrong, but I don't know how. And I just haven't had time to get to the bottom of it. It doesn't have to use RPI GPIO. It can use other libraries, but they're very difficult to install. And it has like a native, experimental native thing where it doesn't have to have any libraries installed, but that doesn't really work very well. And so my only real option was to install both GPIO 0 and RPI GPIO and use the GPIO 0 stuff in my code, which I do. And that mostly works. However, it works about 80% of the time. I don't get any false pages anymore. But now, sometimes when someone rings the bell, it doesn't call me. Most of the time it does. Sometimes it does. I'm not sure if most is correct. But I have sat here with a total emulation of the system and pushed this button, must be 1,000 times at this point. And, you know, sometimes it doesn't work. It just doesn't work. It's not a bounce time issue. Don't know. I just don't know. So anyway, that feature is still a little hinky. So I'll continue to work on that. Anyway. Also, the front door echo cancellation, as you can tell, there is non-existent. You can hear yourself talk when you talk to the front door, which I don't think I'm going to fix because it doesn't really matter that much. So at this point, I'm going to switch over to a bit of a software overview, I guess, of the door client script. Let's see here. Yeah. So I want to, haul out your whiskey. We're going to talk about software. This script has been through a number of iterations at this point. What I wound up doing was representing the duties of the Raspberry Pi in the system with 4 processes. There's something called an unlock listener here, and these are represented here as Python classes, but you can think of them as processes because they end up being processes. There's an unlock listener. There's a unlock executor. There's a page listener, and there's a page executor. So, real briefly, I'll go over how all those work. Well, or at least what they do. The unlock listener, all these processes communicate with each other through Python multiprocessing queues. So we start a process that's represented by each of these classes, one process per each of these classes in the main of this script. And the nice thing about Python multiprocessing is that it has this set of IPC inter-process communication primitives, the most useful of which is a queue. And you can just jam almost arbitrary Python objects down the queue and send them to your other process from each other. So the unlock listener listens, clearly, for an unlock request from somebody pushing the button in the UI. And the door server, which lives elsewhere, this is the door client, sends it a message saying, hey, someone wants to unlock a door. And it captures that somewhere down here. You know, there's a bunch of webs. It's basically the WebSocket-y thing. It handles all the WebSocket stuff. And it says unlock queue. Yeah, oops. Unlock queue. This is the meat of what it does. It says someone asked for an unlock, put an item in the queue, and I'm done. And then the unlock executor, if the unlock listener puts one of those unlock in the unlocked queues, we will turn on an output pin for the door that it applied to. And does that right here. Buzzer on. And buzzer off. Buzzer off, man. And the one thing that this pair of things, well, more the unlock listener, is that it actually listens, or doesn't really listen, but it I suppose it listens, yeah. The unlock executor, when it's done relocking the door, it puts an item in a different queue, a relock queue, that the unlock listener listens to, so that it can tell the UI, hey, you know, the door has been relocked. All right, yes, look, let's get through this. So we also have the page listener thing. This list is for change of state of the call button, well, actually the relay that represents the call button in the system, and it adds an entry to the page queue when someone pushes the button. That's pretty simple. It just says when the button is pressed, put something in the page queue. That's about it. And there's another class that handles that queue and executes page requests. It's the page executor, and it essentially when it first starts, it starts up this PGA SUA thing, which is a command line SIP phone application that runs on the Pi, and it puts it in auto answer mode. So whenever you can call the front door anytime you want by dialing the PJ SUA's extension. But in addition to doing that, it actually let's see, it looks for an entry in the page queue, and if it gets one, it throttles the page requests so that, you know, if somebody presses the page button 1,000 times, it doesn't call you 1,000 times, it only calls you once through in the page throttle duration, which I think is 15 seconds or something. But then it actually just makes a call to the SIP, to the paging SIP phone number, which is usually connected to Asterisk and is like a bank of phones that, you know, anybody can answer. And the first one who answers it, the rest of them, their phones stop ringing. And when they answer it, they're talking to the front door. And man, that's about it. I think we're done here. I just wanted to be a completionist about this. So, look, if you have any suggestions about my call button detection stuff, please, oh, for the love of God, please let me know, because I have tried almost everything I can think of. And if you have any questions or comments, I would love to hear them. Thank you.